Your teacher deducted some marks. So let's have a look at first question. We have 2a plus 8 divided by 5a plus 20. So what can we factor from the top, Zoya? We can factor 2, and you would get a plus 4, correct? For the bottom, you would factor the 5 out, and you would get a plus 4 as well. Agreed? Now, before you cancel anything, you would first write your non-permissible, where you take your denominator, and you would say a plus 4 cannot be equal to 0, which means the a cannot be equal to minus 4. Does that make sense? And then you can cancel these guys, and you would say your final answer is 2 over 5. Does that make sense? Okay, so seems like you had the first question correct. By the way, if I was you, rather than just writing all of this in one line, I would write it like this. It makes it more clear for your teacher. Right? Because sometimes some teachers can be fussy, so they'll be like, okay, I don't know what's happening here. But that's the gist of it. What should have been right? I don't see any major problems with that. Second question was x squared minus 3x minus 18 divided by x squared plus 6x plus 9. Now, factor the top first. 1 times negative 18 is negative 18. We need to find two numbers. When you get negative 18, when you add them, you get minus 3. So that's minus 6 and 3, right? So you can factor the top as x minus 6 and x plus 3. Then we're going to say the bottom line is 9. So the two factors are going to be x plus 3, 3. We'll go far. So for the non-permissibles, you will take your denominator and you say x can put the denominator are the same. So there's one permissible value. And in the next step, one of these guys are going to get canceled. So your final answer is just going to be x minus 6 over x plus, which is what you had, and the restriction seems to be correct as well. So there was no problem with the second question. Okay. Let's have a look at 2a now. In 2a, they gave you 3x plus 6 divided by x squared minus 4 times x squared plus 4x minus 12 divided by 2x plus 12. So now we're going to first factor everything. So from here, you can factor the 3 out. You get x plus 2. X squared minus 4 can be written as x squared minus 2 squared, which is x plus 2 times x minus 2. From this, 1 times minus 12 is minus 12. You got to find two numbers. When you multiply them, you get minus 12. When you add them, you get 4, which is 6 and minus 2. So that is going to be x plus 6 times x minus 2. The bottom, you're going to factor the 2 out and you get x plus 6. Okay. Zoya, I see a mistake. Before you do anything, you got to write the non-permissible. Where are the non-permissibles? I don't see any non-permissible values. It doesn't matter if he asks or not. We always have to write our non.
He's like, if
Sorry?
I ask for it, then you can write it. But if I don't, then you don't have to write it.
If I was you, I would always write it. Because anytime you're solving a question, you would have to write the non-permissible. So if I was you, I would say x plus 2 cannot be equal to 0. So x cannot be minus 2. Then we have x minus 2 cannot be equal to 0. So x cannot be equal to 2. Then we have x plus 6 cannot be equal to 0. So x cannot be minus 6. And in the next step, this is going to cancel with this. This is going to cancel with this. This is going to cancel with this. So we just have 2 left. So your answer is completely right. I see no problem with that. But the only thing I can think of is the non-permissible values. That's the only thing I can think of. Is it Lucas who marked it?
Yeah. Mm-hmm.
You ask him specifically why did he take those three marks
For
off?
the first one, he said, did you get x is not equal to -3? And I explained it to him. He's like, he still gave me 7 out of 10. And then for the last
for this one,
yeah.
for this one,
Mm-hmm.
I think he's a very picky guy, so he probably wanted to see something like this.
But I did that
First
again,
9,
and I sent it.
Yeah, I think he's just being a bit too fussy.
And for the last one, he's like, you didn't factor it properly. I don't know.
Okay, I will have a look at the last one. But the only thing I can think of is he's a bit fussy, so he wants you to write the complete thing and then get the answer.
Don't write the non-permissible if I don't ask for it.
Yeah, I think you need to ask him, you need to tell him that he's got to be more specific, as in like why he took the marks off. So now let's have a look at that. You have m squared minus m minus 12 over 3m plus 15 divided by m squared minus 16 over 2m plus 8. So in the first step, we're going to factor. So we have 1 times minus 12 gives me minus 12. Got to find two numbers. You get minus 12. When you add them, you get minus 1. So that's going to be minus 4 and 3. Agreed? So that's going to be m minus 4 and m plus 3. Then for the bottom, you're going to factor the 3 out, and that gives you m plus 5. Now, guys, we need to leave it as divided for now. We need to leave this as divided. Okay, so this is just going to be m plus 4 and m minus 4. And the bottom is you're going to factor the 2 out, and you get 2 times m plus 4. Okay, before you need to write the non-permissible. So if I was you, I would say right here, m plus 5 cannot be equal to 0. So m cannot be minus 5. Then my second denominator I see is m plus 4 cannot be equal to 0. So m cannot be equal to minus 4. And next line, then I'm going to do the flip. Then I'm going to change this division to multiply, and these two terms are going to, okay? When it flips, you get 2 times m plus 4 at the top. And those guys at the top, they land at the bottom. Now, because we got some new guys at the bottom, these are the new guys which we got at the bottom, we got to write these non-permissible values. M plus 4, I've already written that. Now I'm going to say m minus 4 cannot be equal to 0. That's the new guy that came down. So m cannot be 4. And then we're going to cancel. So m plus 4 cancels with m plus 4. M minus 4 cancels with m minus 4. I'm left with 2 times m plus 3 divided by 3 times m plus 5, which is what you have.
Mm-hmm. So
this is perfectly fine. I'll tell you where he's taken the marks off, non-permissible values. Because it's the most important part. You know what's the tricky part of these questions? The non-permissible values. What happens is people forget. They just do the flip straight away. They do the flip straight away, and they forget to take non-permissible and after flip. So he's taken marks off because you haven't written non-permissible values. Yeah, that's the only thing I can think of. And just remember, no matter what question you're doing, Zoya, even if the question doesn't specify write the non-permissible values, you need to write the non-permissible values because it's one of the most important parts of it.
He's like, your factoring was wrong. That's what he said.
No, your factoring was right. He probably just didn't have enough time to look for the reason. But I can tell you the only reason why he took the marks off is because of the non-permissible values. Everything else is correct.
It's actually not fair because my friends did the same thing as I did, and they got out of 10. I don't know why he's being so picky on me.
I know. Yeah, I don't know. Do you have any friction with them? Yeah, no, if I was you, to be honest with you, if I was a teacher, I would have taken 1 mark off here, 1 mark off here, and 1 mark off because of the non-permissible values. So I would have given you 8 out of 10, but then I would have told you why you got 8 out of 10 because you didn't write the non-permissible values. Yeah, so remember, always write the non-permissible values. Just look at this question. You see, these questions are very similar to the ones we're doing, right? Watch. What do you see over here? In every question. Non-permissible values. You always have to write non-permissible values. Does that make sense? So moving forward, even if the question or the teacher says you don't need to write it, just write it. All good? Okay, now let's have a look at this one. 6 minus 2m over m squared minus 9. Now the bottom is easy. That's just going to be m plus 3 times m minus 3, right? That's super easy stuff. Now we got to factor the top. Now, when you factor the top, you realize you have 6 and 2. So both of those can be factored by 2. But if I factor out the 2, if you factor out 2, then you're going to get 3 minus m. But I don't have 3 minus m. I have m minus 3 though. So why don't we factor negative 2 instead of 2? So what you should do is, you should factor negative 2 instead of 2. And if I was you, I would first do this. I would first rewrite this as minus 2m plus 6. Because 6 minus 2m is same as minus 2m plus 6, right? And what's in front of m? Minus 2. I'm going to factor that out. Then you factor minus 2, and the sign will flip, so it becomes m minus 3 over m plus 3 times m minus 3. And we need to write the non-permissibles. We would say m cannot be minus 3 and m cannot be 3. And you would cancel this. So your final answer would just be minus 2 over m plus 3. Does that make sense?
Yes.
You good so far, Zoya?
Yeah.
Okay. Okay, this should be easy. Let's start at the top. 2 times negative 10 is? Negative 20.
Minus 20.
Yeah, got to find 2 numbers, 5 and minus 4. But there's a 2 in front, so divide them by 2. So you get 5 over 2 and minus. So from 5 over 2, 2 is going to come in front of y. So you get 2y plus 5. For the other one, you're just going to get y minus 2. Simple. Then we're going to factor the bottom. 1 times negative 10 is
Minus 10.
got to find 2 numbers. Find. So that's going to be y plus 5. And before you cancel, you need to write the non-permissible. So you would say y cannot be minus 5 and y cannot be equal to 2. And then so your final answer is just going to be 2y plus 5 over y plus 5. Make sense?
Yeah.
Simple stuff. Zoya, there should be a piece of cake for you now.
Yeah.
Okay, good. Let's have a look at this one. We have 25x squared minus 4y squared divided by 10x minus 4y. Okay, how can you factor how can you factor this top?
will
The
be
numerator right here.
5x minus 2y.
You can rewrite this
plus
as 5x whole square minus 2y whole square, which is in the form of a square minus b square. At the bottom, you can factor the 2 out, and you get 5x minus 2y. Now, the top can be further written as a plus b, which is 5x plus 2y, minus, times a minus b, which is 5x minus 2y. And your denominator is 2 times 5x minus 2y. Now, before you cancel, you need to write your non-permissible. So you take your denominator, and you say that cannot be equal to 0. So we're going to say 5x minus 2y cannot be equal to 0. Move the minus 2y to the other side. So we say 5x cannot be equal to 2y. And now we can choose either to isolate x or to isolate y. That doesn't really matter. I'm going to isolate y, so I divide both sides by 2. So y cannot be equal to this. And then you cancel this. So your final answer is going to be 5x plus 2y divided by 2. Danishwar, you understand this?
Yeah.
Pretty simple stuff. If at any point you guys have a question, you just let me know. Okay, Reed, you're good as well so far? Okay, good. Now we're going to talk about multiplying and dividing. So let's start off with a simple example where I give you 4x squared over 3xy. And we're multiplying this with y squared over 8x. Now, before you cancel anything, you need to write the non-permissibles. I see x at the bottom. What's my non-permissible for that? X cannot be equal to 0. And we have y at the bottom. So we say y cannot be equal to 0. X, well, we've already covered that. And now we can start canceling. Guys, look at this. I have x squared at the top. At the bottom, I have x and x. So how many x's do I have at the top? If I have x squared, what does that mean? How many x's do I have at the top? 2 x's, right? At the bottom, I have 2 x's as well. So this x squared can cancel with both of these. Now, I see 4 and 8. Both of those numbers can be divided by 4. So 4 divided by 4 is 1, and 8 divided by 4 is 2. And I see a y and a y squared. Well, one of the y's are going to cancel. So this one y is canceled. And out of this, y squared is going to cancel, and you're going to left with just one y. So what do I have at the top? I'm left with just one y at the top. And at the bottom, I'm going to have 3 times 2, which gives me 6. And these were the non-permissible values. So far, so good?
Yeah.
Good. Then we have d over 2 pi r times 2 pi r h over d minus 2. Okay. Sean, d divided by 2, d divided by d. Can I cancel that?
No, you can't cancel it.
Why not?
Because in the bottom is being like subtracted by.
Very good. Excellent. That was a tricky question. Guys, the most common mistake I've seen is people, they blindly divide this d with this d. You cannot do that. Guys, you can imagine as this. This is d over d minus. This is a different guy than this guy. Okay, whenever there's a plus or minus here, you cannot cancel that. Now, if there was a multiplication, if this was d over d times 2, then this d can cancel with this d. Because this is d and this is d as well. That would have been different. But over here, we don't have multiplied, we have a negative. So this d is not equal to d minus 2, so we cannot cancel that. Keep that in mind. Now, before you can cancel anything, write the non-permissibles. We have r, so r cannot be equal to 0. And then we have d minus 2. So you say d minus 2 cannot be equal to 0, which means d cannot be equal to 2. Okay, now we're going to cancel this 2 pi r. can cancel with this 2 pi r. Okay, so you're going to be left with d and h at the top divided by d minus 2. Everyone gets it?
Yeah.
Okay, so be careful, okay? Don't make any silly mistakes. All right. So Zoya, next up I have this. I want you to tell me how to do this, Zoya. I have y squared minus 9 divided by x cubed minus. So tell me step by step, how should I do it? What's the first thing I do?
You can cancel out y with y.
No, that would be the most common mistake. This is y squared minus 9. This is y plus 3. We need to first factor everything out. I have y squared minus 9. You can think of this as y squared minus 3 squared. And what's y squared minus 3 squared going to be? Y plus 3 times y minus 3.
Yeah.
Understood? And then I have x cubed minus x. What can I factor out of these two? I can factor out one of the x, right? And the leftover is going to be x squared minus 1. But look, I can rewrite x squared minus 1 as x squared minus 1 squared. So I can further factor this and write it as x plus 1 times x minus 1. So I can further factor that and write this as x plus 1 times x minus 1. Now this, from here, I will factor one of the x's. So that would just be x minus 1. And at the bottom, we have y plus 3. Does that make sense?
Mm-hmm.
Now we need to write the non-permissibles. Okay, Zoya, I want you to permissible step by step, starting with this, then this, then this, then this.
X
For the first one,
-1,
yeah,
and x cannot be 1,
yep,
and y cannot be -3.
very good. And now y plus 3 is going to cancel with y plus 3, and this 1 is going to cancel with x minus 1. This x is going to cancel with this, and my leftover is just going to be y minus 3 over x plus 1. And my non-permissible values are written over here. So far, so good, guys?
Yeah.
Naneshwar, you're good? Okay, I'm assuming you're good. Okay, Daneshwar, I want you to tell me how to do this question now. We have x squared minus x minus 12 divided by x squared minus multiply with step by step. I want you to tell me each and every step, Danish. Let's go.
You factor out the top and bottom.
Okay, so let's start off with this guy first. With this guy, let's factor that out. What would that be?
Repeat x minus 4 and x plus 3.
Good. So 1 times -12 is going to give you -12. Got to find two numbers. When you multiply them, you get -12. When you add them, you get -1. So that's -3. So that's going to be x minus 4 times x plus 3. Okay, the bottom is simple, a square minus b square. So it's going to be x plus 3 times x minus 3. Okay, now we get to this guy right here. 1 times 3 is going to give me 3. Got to find two numbers, which is -3 and -1. So we get x minus 3 and x minus 1. From the bottom, you can factor the x out and you get x minus 4. Okay, Danish, now.
Non-permissibles.
Good. Tell me all the non-permissibles going left to
X
right.
cannot be -3.
Yep.
X cannot be 3.
Yep.
X cannot be 4.
Perfect. And now we can start canceling. X minus 4 cancels with x minus 4. X plus 3 cancels with x plus 3. Minus 3 cancels with x minus 3. 3 minus 1 divided by x. Pretty simple stuff so far, correct? Okay, good. All right, guys. Now you guys are going to do the next question yourself. I have m squared minus 6m minus 7 divided by m squared minus 40. And I want you to plus 8 plus by m squared plus. Okay, you're going to do this yourself, and you get 5 minutes. Let's go.
Got it.
Good. So the key over here is, guys, when you factor everything out, you need to write the non-permissible before the flip, and then you change it to multiply, you flip this, and then you need to check for the new non-permissibles, okay? You need to add those to the list. That's the key. Okay. The next one should be super simple. You should be able to help me out on that. We have 3x plus 12 divided by 3x squared minus 5x minus 12 divided by 12 over 3x plus 4 times 2x minus 6 over x plus 4. So we're going to factor everything out. From here, we factor the 3 out. We get 3 times x plus 4. From the bottom, we can do 3 times negative 12, which gives me minus 36. You got to find two numbers. When you multiply them, you get minus 36. When you add them, you get minus 5, which is going to be minus 9 and 4. But there's a 3 in front, so we need to divide it by 3. We get minus 3 and 4 over 3. So at the bottom, we're going to have x minus 3. And the 3 from 4 over 3 is going to land in front of x, and that's going to become 3x plus 4. Okay. So that's that. We're going to keep it as divided for now. And we get 12 over 3x plus 4. Factor the 2 out of this one. You get minus and this x plus 4. Now we need to write the non-permissibles, okay? It's very important to write the non-permissibles before the flip. So left to right, guys, everyone, what's the non-permissible? X cannot be 3. X cannot be minus 4. X cannot be minus 4. Okay, in the next step, you're going to change from divide to multiply. We're going to change this from divide to multiply. So 3x plus 4 goes to the top. 12, because one stays as it was multiplied. Okay, now, because we flipped this guy, a new guy came to the bottom, but do I have any non-permissible for this? That's just a number, right? So we don't really have any non-permissible for that. So that's fine. And now we can start canceling. X plus 4 cancels with x plus 4. 3x plus 4 cancels with 3x plus 4. X minus 3 cancels with x minus 3. At the top, we just have 3 times 2, which is 6, divided by 12, which is just 1 over 2. Okay, does that make sense?
Yes.
Yeah.
Okay. Simple. All right. Let's do plus or minus. Did you guys start addition or subtraction, guys?
Yeah.
Okay. And Sean, what about you? You must have just started the chapter, so I don't think you must have got into that.
Oh no, we did this chapter before.
Okay, yeah, you've done this chapter. I see.
Yeah.
I see. Okay. Okay, we have, let me find a trickier one. I have 2x over xy plus 4 over x squared. So this is the question. Guys, if I want to add or subtract them, we need to get the common denominator. So this is how you get the common denominator. Okay. First, we're just going to look at x. I have x here. Tell me what's the largest power of x out of an x, or which one is the largest power of x?
X squared.
So that's going to be that. Y here, so we're going to have to add a y. Now this is my common denominator. Now we come to this. Zoya, tell me, this one had x and y. So what was this guy missing? It was missing the extra x, right?
Mm-hmm.
You can imagine you times it by x at the top and at the bottom. So this is going to be 2x times x. 2x times x is going to be 2x squared. Agreed? This one has x squared, so this one has this, but this one is missing y, so it needs a y. So imagine you times the top by y. So you'd multiply it with the missing guy, 4 times y. All good so far? Can we write the non-permissibles? I have x squared and y at the bottom. What's the non-permissible? X cannot be equal to 0, and y cannot be equal to 0. Agreed? Oh, by the way, there was another term. This one had a term of -3 over here. So there's another thing. Now -3 can be thought of as -3 over 1. -3 was the opposite. It was missing x, y. So we're going to multiply it with the x squared, and we're going to multiply it with y. So that's just going to be -3x squared y. And now you write the non-permissible for the bottom, guys. You say x cannot be equal to 0, and y cannot be equal to 0. Now, we can't really do anything with these guys, so we're good for that. Does that make sense? Okay. All right. Zoya, do you have any question?
No.
Okay, you're good with this, right?
Yes.
Okay. Now, I have 4 divided by p squared minus 1 plus 3 divided by p plus. Okay, let's get the common denominator of them. P plus 1. Firstly, we can factor this as p plus 1 and p minus 1. And this is just going to be p plus 1. Now, when we get the common denominator, we know it's going to be p plus 1 and p minus 1. Now, was this guy missing anything? It wasn't missing anything, so that's just going to be 4. This guy had p plus 1, but it was missing p minus 1. So imagine you're cross-multiplying it with p minus 1. So it's going to be minus 1. So this is just going to be 4 plus 3p minus 3 all over p plus 1 times p minus 1. Now, we can write the non-permissible for the bottom, where we have p cannot be minus 1 and p cannot be positive 1. And the top, we can simplify it. 3p, we have 3p, and 4 minus 3 is 1. And the bottom is just going to be p plus 1 times p minus 1. Simple? Okay, you guys get it?
Yeah.
Okay, good. So Zoya, the rest of this stuff, I have my videos up already, so you can watch the rest of it. Okay, you already have access to those. And now we're going to move on to trig. So we'll do a little bit of trig. And then we'll do a little bit of reciprocals afterwards. Okay.
I'm
So we're going to start off. Yeah.
Another class minutes. Can I use source function?
Oh, sure. Yeah.
All right, thank you.
Yeah. No. Okay, let's go first. So first thing you need to know, this is your quadrant number 2, this is your quadrant number 3, and this is your quadrant number 4. You need to know your quadrant. So guys, if I have an angle of 60 degrees, by the way, this is 0, this is 90 degrees, this is 180 degree, this is 270 degree, and when you make one full circle, you're at 360 degree. Agreed? We talk most of the time because this is for you.
Okay.
So read, if I have an angle of with the axis. Okay. Now, if I tell you I read which one. Okay, you guys can. Okay, can you guys see the screen now?
Yeah.
Okay, so this is 120, this is 180. The reference angle is the angle that it makes with the nearest x-axis. This one right here. And that is just going to be 180 minus 120. So you see from here to here, it's 120.
Yeah.
All the way, it's 180. So this is just 180 minus 20, which is also 60. Now, if I have an angle of 225, which
30.
quadrant is 225 in? Good. So 225 is going to be here. This is 180. Your reference angle now is going to be this, which is 225 minus 180.
45.
If you do that, you should get 45. If my angle is 300, which quadrant is 300 in?
Fourth.
Fourth. This is 360. So now your reference angle is going to be this, which is 360 minus 300, which is 60 degree. Simple stuff?
Yeah.
Okay. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. This is 0, 90, 80, 270, and 360. Okay, this one falls in quadrant 1, so reference angle is going to be the same angle. This one falls in quadrant 2, reference angle will be 180 minus that, which is 60. This one falls in quadrant 3, reference angle will be this angle minus that. This one falls in quadrant 4, it would be 360 minus this. Okay, very simple stuff. Okay. Next up, you need to know your special angles.
0, 30, 45, 60, 90.
So your special angles are 0, 30. Okay, and you need to know the sine cosine. We use our finger formula. Sine theta is square root of fingers on the right over 2. My cos theta is square root of fingers on the left over 2. And my tan theta is square root of fingers on the right over square root of fingers on the left. Now, how many of you guys already know this method?
Yeah.
Okay, you remember this method where I'm just trying to draw this, but I'm a poor artist. Okay, so this is, imagine this is my left hand with my palm down. This thumb is my 0 degree. This is 30, this is 45, this is 60, and this is 90. This is my left hand on the table with my palm down. Okay, we're going to be using this. Okay, I'm going to ask you guys randomly. Read, if I want to find sine 30, what you're going to do is, you're going to bend your 30 degree finger, which is this. So bend that and tell me how many fingers are on the right, because the formula for sine is square root of fingers on the right over 2. So how many fingers are on the right? So sine 30 is just going to be square root of 1 over 2, which is just 1 over 2. What about sine 45?
Square root 2 over 2 or 1 over square root 2.
Excellent. That can be rewritten as 1 over square root 2. What about sine 60?
Square root 3 over 2.
Good. What about sine 0?
0.
That's just going to be 0.
1.
And sine 90? I want you to know. Remember this, okay? Off the top of your head. Okay, now we're going to do the same for cos. Let's do cos 0. Cos is square root of on the left. So how many fingers are on the left?
4.
2 over 2, which is 1. What about cos 45?
Square root 2 over 2 or
Excellent. And what about cos 60?
square root 1 over 2 over 2.
Excellent. Cos 30
Square root over 2.
and cos of
0.
good. So again, as you can see, the cos and the sine are swapped. Cos 0, 1, the cos 0. Again, I want you to remember these two off the top of your head as well. Okay, so we did it for cos, and let's do it for tan now. Okay, if I'm going to find tan of 45,
Square root 2 over square root 2.
good.
Or just 1.
That is just 1. So tan 45 is 1. Tan 30,
1 over square root 3.
square root 1 over square root 3, which is just 1 over square root 3, because it's square root fingers on the right, fingers on the left.
Okay.
Tan 60,
Square root 3 over square root 1. So just square root 3.
very good. And tan 0,
0.
good. Tan 90,
Undefined.
very good, because it's going to be square root of 4 over square root of 0, right? Anything over 0 is undefined. Very well. Okay, rest of you guys, are you guys following so far?
Yeah.
So guys, these are the formulas. These are the formulas that's going to make your life easy. Remember these. Sine theta is square root of theta is square root of fingers on the left over 2. And tan theta is square root of fingers right over square root of on the left. Okay. We're going to start off with some simple examples. I want you to find this sine of 180, then find cos 180. Then we're going to find sine of 270 and cos of 2. And so to find sine of 180, you're going to first make 180. And then you write add. What this means is sine cos positive. Over here, only sine is positive. Everything else is negative. Cos and tan are negative. Over here, everything else is negative. Over here, only cos is positive. Everything else is negative. So, what was my reference size?
0.
So I would say sine of 180 is just going to be sine of reference angle. However, on this side, my sine is positive. On this side, my sine is negative. So what am I going to put here, plus or minus?
It doesn't matter because the answer is 0.
Excellent. Very good. So this is just going to be sine of 0. Sine of 0, which is just 0. Now let's look at the next question, which is sine of 270. So I first need to make 270. Now 270 is going to fall right here. Okay, this is 270. And the reference angle is the angle that it makes with the nearest x-axis. Okay, so guys, look, You can either think of this x-axis or this x-axis. The reference angle is 90. And then you write add sugar to coffee. So now you're going to say sine of 270 is sine of reference, which is sine 90. However, look over here. It's C, so sine is negative here. This is T, so sine is negative there. What this means is, in both of the quadrants, sine is negative. So we're going to have to put a negative here. So my final answer is going to be negative. And what's sine 90? I told you to remember this off the top of your head. Sine 90 is 1. So this is going to be minus 1. I want to find cos of 180. I'm going to make 180 first. And he's going to be right here. And I know my reference angle is 0 for that. And I'm going to write add sugar to coffee. Add sugar to coffee. So now we're going to say cos of 180 is going to be cos of just 0, except both of these quadrants are negative for cos. Both of these quadrants are negative for cos. And what's cos 0? 1. So it's going to be negative 1.
1.
Next up, we're going to find cos of 270. 270 is right here. Reference angle for that is 90. And then you write add sugar to coffee. So we're going to say cos of 270 is just going to be cos 90. However, I have a problem. Over here, my cos is positive. Over here, my cos is negative. So is it going to be plus or minus? It doesn't matter.
0.
Good. It doesn't matter because my cos of 90 is just 0. So just remember, if you ever run into an issue, if you ever run into a scenario where one quadrant is positive and the other quadrant is negative and it's right in the center, most likely the answer is going to be 0. Okay? So which quadrant is that going to fall in? Reference angle, which is going to be 225 minus 180, which is 45. And then we're going to write add sugar to coffee. So you say sine of 225 is just going to be sine of 45, except in this quadrant your sign is negative. And sine 45 you can get using your fingers. It's square root 2 over 2.
Negative 1 over square root 2.
Or you can write it as minus 1 over square root 2. Now, Reet, I want you to be careful. Most of your teachers don't want to have a square root at the bottom, so they're going to expect you to rationalize this. So it's best to write it like that.
Okay.
All right, good. Sean, tell me step by step, how would I do?
Yes.
Which is 60. And then you write add sugar to coffee. So you're going to say cos of 120 is going to be equal to cos of reference, which is cos 60. X going to be negative. And you're going to give me cos 60 using your fingers. Give me cos 60, Sean.
Square root 1 over 2, so 1 over 2.
Very good. So your final answer, exactly. Your final answer is minus 1 over 2. Pretty simple stuff, correct?
Yeah.
Okay. Zoya, you're going to tell me how to do the next one? Step by step. Let's go. Tell me how should I find tan of 300?
Quadrant and number 4.
Good. Next step.
And then you subtract 300 by 270.
No. Reference angle is the angle that it makes with the nearest x-axis. Remember that, not with the y, always with the x-axis. So this is your reference angle. Be very careful. Okay, everyone, I want you to say 10 times. Reference angle is the nearest angle that it makes with the x-axis, not with the y, but x-axis. That's a common mistake. A lot of people think it's this. No. It always has to be from the x-axis. So it's 360 minus 300. So what's my reference angle, Zoya? Excellent. And then you write add sugar to coffee. So you're going to say tan of 300 is just going to be tan of 60. Except in this quadrant, my tan is going to be negative. So we're going to put a negative there. So tell me the value of tan 60 using the finger method. So bend your finger, yeah?
3/1.
It's square root of fingers on the right, so it's square root of 3 over square root of fingers on the left. So it's negative square root 3. So that's why, again, Zoya, it's very important to say the square root. I know, I see many kids, you know, they get complacent and they don't want to say the square root. If you don't say the square root, you're not going to put the square root. Okay. So everyone, before we move on, I want you guys to say this out loud. Sine theta is square root of fingers on the right over 2. Cos theta is square root of fingers on the left over 2. Tan theta is fingers over left. Make sense? Okay, good. Cos of, let's say cos of 240. Danishwar, I want you to tell me how to do this step by step. Hello, Danishwar.
Yeah.
I want you to do the step.
First, you add sugar to coffee.
Okay.
And then
And
you draw the angle and find the reference angle. And the third one.
And this is 180, so my reference angle is going to be 240 and 180, which is so we're going to say cos of 240 is just going to be cos of reference angle, which is cos of 60, except here cos is
Square root of 1 over.
okay. Do you guys understand this?
Yes.
Yep.
You know, next up, what's going to happen is they're going to ask you to think backwards. They're going to say, actually, they can give you one other thing. So they could ask you to find sine of 840. Okay. Now, anytime you have an angle which is between 0 and 360, we can use something called coterminal. Have you learned about coterminal in class yet? Reed, have you heard about coterminals?
Yeah.
If you have an angle of 840, to get the coterminal, we want to bring this angle between 0 and 360. So you just keep subtracting 360 from it. If you keep subtracting, what do you get? Did you get 60?
Yeah.
So we're going to say this is going to be same as sine of 60. And that is simple. It's just our special angle, square root of 3 over 2. So if your angle is, you know, if they had asked me to get cos of minus 1050, then we would just take this minus 1050 and keep adding 360 until your angle is between 0 and 360. That's the key. Okay, can you guys keep adding this? Minus 1050 plus 3 360 plus 360. Maybe you have to do it
30.
once more. You get 30. 30 or negative 30?
30.
Okay, so that was just 30. If they cosine of minus 1050 is just going to cosine of the
Square root 3 over 2.
square root of 3 over 2. So whenever your angles are really big or really small, you can just use coterminal. Now, what's the meaning of coterminal? Okay, if I tell you, you know, if I give you an angle, if I tell you an angle of 60 degree here, if I make one full circle, guys, how much is one full circle in degrees?
360.
360, right? So my next angle is going to be 60 plus 360, which is 420. Now, if I'm at 420, I can make one full circle again. That's going to be 420 plus 360, which is 780. Now, guys, look at this. All these angles are in the same angle, okay? They're just 360 degree or some factor of 360 degree apart from each other. But the values they're going to give me is the same. So if I ever ask you to do 780, you just keep subtracting 360 until your angle is between 0 and 360. And we know how to find the values of angle between 0 and 360. Okay? Is going to be minus 300. That's also a coterminal. If I go once more, in the side, that's minus 100 minus 360, which is minus 660. So I can keep going over and over. There's then coterminals, and I just the same place. They can give me the same reference. So the value is going to be the same. Okay. So anytime you have an angle which is really large but a negative number, adding 60 until your angle is between 0 and 360. Really large positive number, keep subtracting 60 between 0 and 360. Simple stuff. Okay. Last question for these types. Now, sometimes you're going to have to use your calculator. What if I give you this? So read, this is a really large negative number now. So normally, if you take this and you keep adding 360, you're going to go nuts by the time you get to a number between 0 and 360, right? So there must be a trick to this. And you know what? Tell me something. How many degrees are there in one full circle?
360.
360. So what if I just divide this number by 360? Divide this number by 360. What do you get?
Negative 55.7.
Now, what this means is I don't really care much about the negative. All this means is I have 65 full circles.
It's negative
Right?
55. 55.
55? Okay.
Yeah.
So I have 55 full circles. That's all I care about. 0.7, I don't really care about that. I know I have 55 full circles, and each circle I know is 360. So what's 55 times 360?
19,800.
19,800. All I'm going to do is I'm going to take this angle, and I'm going to add 19,800 to it. What do I get?
39,910.
No, no, it can't be that big. It's negative plus that.
Negative 310.
Negative 310. Now we just need to add 361 once more to between 0 and 360. 50. So we're going to say this is just going to be 1050. Okay, so you're just going to make your quadrant. You know 50 is going to fall here. You know the reference angle is going to be 50. And when you write add sugar to coffee, We know that's just going to be positive. And now you can just plug in tan 50 in your calculator because this is no longer a special angle. So now we're going to have to use calculator. What's tan 50? Make sure it's in degree mode.
I don't have my calculator on me.
Okay, anyways, can one of you guys punch in tan 50 and just make sure it's in degree mode?
Yeah, I got 1.19.
There you go. So they could give you a question like that. Okay. Simple, read?
Yeah, I got it.
Okay, good. Now they could give you something like this. They could say 2 sine theta plus square root of 3 is equal to 0. And they're going to say find theta if your theta is between 0 and 360. So what we're going to do first is we're going to isolate sine theta. So minus square root 3 goes to the, it's going to become minus square root 3 over 2. Guys, what's the formula for sine theta? The finger method one.
Root of fingers on the right over
The
2.
right. Now look at this. This is 2, this is 2. This is going to tell me how many fingers are on the right. I have 3 fingers on the right. So guys, I want to have 3 fingers on the right and then bend the reference angle. So I have 3 fingers on the right. What's that reference angle equals to?
60, negative sine 60.
No, we don't care about the negative. We're
Oh.
just going to write the reference angle because for reference angle, we don't care about the negative. And then all I'm going to do is I'm going to make this quadrant. I'm going to write add sugar to coffee. Guys, look at this. Was the value of sine positive or negative?
Negative.
So I need to draw it where my quadrants are negative for sine. These are these guys right here. And the reference angle in each of them is going to be 60. Now we know this is 180. So this guy is going to be 180 plus 60, which is 240. That's my first answer. We know this is 360. So this angle is going to be 360 minus 60, which is 300. That's my second answer. So you're going to say your theta is equal to 240 or 300. This is how you're going to tackle those questions. Does that make sense?
Yeah.
Sean and Danishwar and everyone else, does
Yeah.
it make sense? Okay, next up I have cos theta. Square root of 2 cos theta plus 1 is equal to 0. And again, you're going to find theta if your theta is between 0 and 360 degrees. So as a first step, you're going to isolate cos theta. Cos theta becomes minus 1 over square root 2. Now we know we can rewrite this as square root 2 over 2. That's very important, folks. Why? Because what's the finger method for cos? Square root of fingers on the left over 2. So it's very important to know that you can rewrite this as that. Now look at this. This is 2 and 2. That means how many fingers are on the left? How many fingers are on the left, folks?
2.
So what's my reference angle that needs to, what's my reference angle going to be? 45, right?
Yep.
And then I'm going to make my quadrant. I'm going to write add sugar to coffee. Is the value of cos positive or negative?
Negative.
So I need to draw where cos is negative, which is here and here. So I have 45 degree here and 45 degree here. This is 180. This angle is going to be 180 minus 45. What's 180 minus 45? 135. And this is 180 plus 45, which is how much?
225.
225. So your final answer, you're going to say your theta is equal to 135 or 225. Does that make sense? Now, read. They can trick you. You know what they can say? So they will say the domain is only from 0 degree to 180 degree. That means now you need to write your answers between 0 and 180. If this was your domain, then the only answer would be any answer that falls from here to here, which would only be 135.
Okay.
Okay, so be careful. Sometimes they might change the domain. Okay. All that means is you only need to write the answers which fall within those degrees.
Okay.
Okay, good. Everyone, I want you to do this one. Let's go. Give me the theta. Let's go, everyone. You get 5 minutes. So what's the first step, Zoya?
So what I did is 10 equals square root of fingers of the right over square root fingers on the left.
Mm-hmm.
I didn't do the rest.
Yeah. And we know square root of 3 can just be written as square root of 1, right? Because that's just square root of 3, right? So we know how many fingers are on the right. How many fingers are on the right? Look over here. How many fingers are on the right?
3.
So what's my reference angle? I need 3 fingers on the right. What's that reference angle? That's going to give me 60. And then you write add sugar to coffee. Now, the value of tan in this case is positive. So write where tan is positive, which is here and here. So I have 60-degree reference angle here and a 60-degree reference angle here. Well, this is just going to be 60. And this is going to be 180 plus 60, which is 240. So you're going to say your theta is equal to 60 degrees or 240 degrees. Does that make sense, folks?
Yeah,
How many of you guys got this?
I got it.
Okay, very good. Now I have cos theta is equal to minus 0.25. Be very careful. This is a super simple question, but I've seen people mess up on this. Now, guys, if you look at this question, you know, clearly this is not a special angle value, so I'm going to have to use my calculator. So the first thing that you need to find is your reference angle. And for that, you would just do inverse cos, second cos. Ignore the negative. Put this negative in here. It's just going to be inverse cos of 0.25. Make sure your calculator is in degree mode. Punch it in. What's inverse cos of 0.25?
70.52.
70.5 degrees. So now what you're going to do is you're going to make your quadrant, and the value of cos was negative. So you need to draw it where cos is negative, right? Add sugar to coffee. Cos is negative over here. And over here. So I have a reference angle of 75.5 here and a reference angle of 75.5 here. If this is 180, 180 minus 75.5 is how much? What's 180 minus 75.5?
104.5.
Say that again loudly. 104.5?
Yeah.
Okay, and the second one is going to be 180 plus 75.5.
255.5.
255.5. So those are going to be your answers, folks. You're going to say your theta is equal to 104.5 or 255.5. Does that make sense? Reed, you're good with this stuff?
Yeah.
So this is where people are going to make a mistake. What they're going to do is they're going to put the negative in there. That's going to be the biggest mistake. Remember, we're trying to find the ref angle only, okay? For that, you just plug in the absolute value of that. This negative is just going to tell me which quadrants they're going to fall in at. So that's a bit different. I think we can cover the rest of it. Wait, are you good for now?
Yeah, I'm good. Thank you.
Okay, good. Now we're going to talk about reciprocals. Okay. Guys, if my number is -2, you just flip it, but sign stays the same. Now, if I had given you -3/4, reciprocal of that is going to be -4/3. Okay. What about if I had 100? What's root of 100?
1/100.
1/100. Very good. So you're just going to flip it. That's the meaning of reciprocal. Okay. The most basic reciprocal graph that you're going to see is 1/x. Okay. The most basic reciprocal graph is going to be 1/x. Okay. So this is what we're going to do. Pay attention. All I'm going to do is, what's my denominator, Sean?
X.
I'm just going to draw my denominator graph first. So watch, I'm going to draw my denominator graph, x. And that's just mx plus b, right? Think of this as
Yeah.
mx plus b. So clearly value is 0, and m is the number in front of x, which is 1. So your slope is 1/1, which means you're going to go 1 over and 1 up. So when I graph this y equals to x, it's going to look like this. Okay. This is the graph. This is going to have a x-intercept or y-intercept at 0, and slope is going to be 1 over 1 up. And you're going to just connect these lines. This is your y equals to x graph. Understood?
Yeah.
Okay, Sean, tell me, this is the x-intercept, right?
Yeah.
The x-intercept is at 0, the y-intercept is at 0. Okay, when you take, what's the y value right here, Sean?
0.
Now, when you take a reciprocal of 0, what are you going to get? 1 over 0?
Yeah.
And 1 over
Oh,
0 is
undefined.
undefined. So what that means is that is where you get your vertical asymptote. So when we draw our new graph, I'm going to draw my new graph in red. That's going to be your vertical asymptote. Okay. So this is going to be your vertical asymptote. So you're going to say for the new graph, your vertical asymptote is going to be at the y-intercept or at the x-intercept for that, which is at x equals to 0. And I want you to remember for all these graphs, the horizontal asymptote for all these graphs is always going to be at y equals to 0. Remember that. And now we're going to draw the rest of it. Okay, guys, I have a question for you. Look at these y values. These y values are becoming really large, right? Like 100, 200, 300, 1,000. Tell me something. What's a reciprocal of 100 going to be?
1/100.
Which is like 0.01, right?
Yeah.
Right? Which is a really small value. So all I'm asking you is this. Reciprocal of a really large number is a really small number. Now, my points on the new graph are going to be really, really small right here. Almost near 0, but they're never going to touch 0. But now, as I get closer, okay, now look at the original, the green graph. Sean, what's happening to the y values? What are the y values becoming?
They're coming smaller.
Small, right? And let's say it's like 0.01. What's the reciprocal of 0.01? 1 divided by 0.01 is going to be 100.
0.01 over. Yeah.
No, 1 divided by 0.01 is 100. So what I'm trying to say is, when you take a reciprocal of a really large value, you will get values. When you take a reciprocal of really small value, you get a really large value. So what I mean that is, this graph is getting really small for y values. The reciprocal is going to get really large. So this reciprocal value of y is going to get really large as you get close to that 0. And these are your really big y values. So your reciprocal of really large values is really small. It's going to get real close to 0, but it's never going to touch it. But as long as now we'll talk about this guy right here. Sean, what's happening to the y values right here? They're becoming really,
They're getting smaller.
they're becoming negative. No, they're becoming really large negative values, right?
Oh, yeah.
They're becoming really large negative value, like minus 100, minus 200, minus 1,000. What's reciprocal of really large value
Really
going to be?
small.
Exactly. But they're going to stay negative. So they're going to be below the x-axis like that. And over here, now your negative values are becoming really small, like 0.01 or something. So reciprocal of that is going to give you a really large negative value. So what that means is this is going to get really like that. So you see the graph that I've drawn in red?
Yeah.
That's my reciprocal graph of y. Okay.
So
So,
what point
and
do you
then-
want to like make the red graph? Like
Okay.
what point?
It's just an approximation, but these 2 points where the red graph crosses with the original graph, this
Yeah.
point is called invariant point. Invariant means it does not change. So this point and that point, these are your invariant points, means these 2 points do not change. Okay, you know for what y values are going to get, you're going to get invariant points? When you have, if you want to find your invariant points, all you do is you make your y equals to 1. If your y is 1, what's the reciprocal of 1 going to be?
1/1?
Which is just 1. So did the point change?
No.
That's why it's invariant. Or when your y value is minus 1, what's the reciprocal of minus 1?
1/1. So
Which is minus 1. So so you see these points are not going to change. What I mean by that is if you're ever trying to find invariant points, you make y equals to 1 or y equals to minus 1, and you solve for x. And you don't even need to put it in here. You can just put it right here in the other one. So when you put y equals to 1 here, x becomes 1. So your invariant point is 1, 1. And then you put y equals to minus 1 right here, your x becomes minus 1. So you would say your point is minus 1, minus 1. So these two are your invariant points, right? Which are these points right here. It's going to make more sense when we do a couple more examples. So this guy and this guy are your invariant points. The example. Okay. If I ask you to graph 1 over 2x minus 3, what's my denominator, Sean?
2x.
So what we're going to do is we're going to graph that separately first. Now look at this guy, mx plus b. Think about mx plus b. Where's the y-intercept? B value, minus 3. And your slope is 2, right? Which is 2 over 1, which means you go 1 over and 2 up. Agreed with me?
Yeah.
Okay, we're going to make this graph. My y-intercept is at minus 3. So that's at minus, which is right here. And then I go 1 over and 2 up, which is right here. And then I'm just going to join these lines. So that's my denominator graph. Agreed?
Yeah.
We need to find this x-intercept. How do we find the x-intercept? We're going to make our y equals to 0, right?
Yeah.
And that's going to give me 3/2, which is 1.5. This is your x-intercept. So we know this value right here is going to be at 1.5. Agreed?
Yeah.
And then that's where you're going to have your vertical asymptote.
So your vertical asymptote's also your x-intercept?
X-intercept of the denominator. Yeah. Because that's your non-permissible value. Look at this. That's your non-permissible value. What's the non-permissible for this? 3/2, which is 1.5. Non-permissible means it's going to give me a vertical asymptote. Agreed?
Yeah.
Horizontal asymptote, remember this, will always be at y = 0. So this right here is going to be your horizontal asymptote. Now what's going to happen is we're going to use the same logic. Sean, what's happening to the y values as they're getting real close to this? The y value is really
Small.
so reciprocal is going to get really large. Now what's happening as we go for a, values are getting really large?
And big. So their reciprocal's gonna be really small.
Pretty much it's going to get real close to the asymptote, but it's not going to touch it. Okay? Now same over here. What's happening to the y values here? They're becoming large, but they're negative. Reciprocal is going to be negative, but it's going to be really small like that. Now over here, your y values are getting really small, but they're negative. So reciprocal is going to be really large, but negative. Understood? And these points right here are your invariant points. So how are you going to get your invariant points?
And this always gonna be for the negative side, so we -1, minus.
No. The points are not always going to be the same. Invariant point is when y is equal to 1 and y is equal to -1, and you're going to have to solve for x. X is not always going to be -1. You're going to have to solve for x. So over here, you plug in 1 first. So y is 1, and we're going to have to solve for x. So 2x is equal to 4. X is equal to 2, means your point is 2, 1. Now, for the second one, so you put -1 right there. So -1 is equal to 2x minus 3. So -3 goes there, becomes +3. 2x is equal to 2, x is equal to 1. So 1, -1. So this point right here is your 1, -1 point. And this point right here is your 2, 1. These are your invariant points. Same over here. Understand? Okay. So this is how it is. Are you good so far?
Yeah, I'm good.
Okay. Let's try another one. Let's see. Okay, what would you do first? You would first
Go
graph
to
the
the
bottom, right?
Yeah.
So that's 5x plus 7. You vary your, and think about mx plus your y-intercept. Let's make it, that's fine. Your y-intercept is at 7, and your slope is 5/1, which means you go 1 over and 5 up. Make sense? Okay, so we're going to make this graph now. Y-intercept was at 7, so let's say this is your 7. Let's say this is 7. Then I go 1 over and 5 up. So let's say that's where you get the point. So you've joined that line. Now we need to find this x-intercept right here. Understood? How do you get that? You make your y equals to 0. So 5x plus 7, x is going to be minus 7 over 5. Can you punch in minus 7 over 5 in your calculator?
It's minus 1.4.
Minus 1.4. Means this guy right here is going to give you your vertical asymptote. So your vertical asymptote, you would say, is that x equals to minus 7 over 5, which is roughly minus 1.4. So at this point, you make a vertical asymptote. Your horizontal asymptote will always be at y equals to 0. So at this point, you make your horizontal asymptote. Okay, now, very simple concept. Sean, what's happening to the y values? They're becoming really
Small. Small.
so your reciprocal is going to get large. Over here, your reciprocal is going to get small because your y values are becoming small, becoming large, sorry. Your y values are becoming large, so your reciprocal becomes small. Now we're going to do it for this part. Look over here. What's happening to the y values right here? They're becoming really small, but they're negative. So your other guy is going to become large but negative, and then it's going to become small but negative. And so you can find the invariant points by making y equals to 1 and y equals to minus 1. But I'm going to let you do that. Do you understand?
Yeah.
Now, so far, we've only been working with linear equations. We also need to know how to get reciprocal of quadratic equations. Okay, so now we're going to get the reciprocal of quadratic equations. So if I tell you the question that I want to graph is 1 over x squared minus 4. I want to graph this. What's the first thing you're going to do, Sean? You're just going to graph the bottom. Now this is quadratic. Sean, how do we graph the quadratic thing we get?
The vertex.
Okay, what's the vertex? What's the vertex for this, Sean?
Would you minus b over 2a?
No, vertex.
No.
Come on, what's the number
Oh.
inside the square? Nothing, 0. This is minus 4. The vertex is 0, minus 4. Super simple. Okay, so my vertex is at 0, minus 4. Which is roughly over here. Okay, and then we do 1 over 1 up, tada, tada, tada. We it's going to open up like that. Okay, then we're going to get the y-intercept. To get the y-intercept, you make your x equals to 0, so that's at minus 4. Then we're going to get the x-intercept, so you make your y equals to 0. So from there, you get x is plus or minus 2. So this x-intercept is at 2, and this x-intercept is at minus 2. Wherever you have the x-intercept, those guys are going to be your
The
vertical
vertical
asymptote.
asymptote.
There you go. This is going to be your vertical asymptote, these two guys. So you will say you have a vertical asymptote at x equals to 2 and at x equals to minus 2. Does that make sense?
Yeah.
And we all know horizontal asymptote will always be at y equals to 0. So you can make your horizontal asymptote at y equals to 0 right here. Okay, and then we're going to just use our simple concept. Look over here. Y values are getting small. So what's going to happen to the reciprocal? It's going to get
Big.
large. And then it's going to get really small. So the outside guys are super easy. Same for here. Y values are getting small, so your reciprocal is going to get really large. It's the center part that you have to be careful about. This was that this vertex y value is -4, right? What's the reciprocal of -4 going to be?
-1 over 4.
Which is 0.25. See, that point is going to become this point now. Understood?
Yeah.
Now look, what's happening to the y values? They're becoming really small negative values. That means reciprocal is going to become really large negative value. Same over here. What's happening to the y values? They're becoming really small negative values. So your reciprocal is going to become really large negative value. You understand?
Yeah, and all this is 1 over 1 over 8.
Well, you know what? We don't really need to do this one anymore. Why? Because I know my x-intercept. As long as you draw it going through the x-intercept, the rest of it doesn't matter. It's just a sketch.
All right.
Yeah, but yeah, you're right. It's 1 over 1 up, 2 over 4 up, 3 over 9 up. But the main piece of information is your x-intercept and y-intercept. Now they're going to say, what are the invariant points? So wherever these two graphs intersect, those are going to be invariant points, which is right here. This one right here, this one right here, and this one right here. So how many invariant points do you think this graph will have?
4.
4. So you're going to first make your y equals to 1, and then y equals to -1. Okay, and you will plug it in right here. So when your y is 1, this is x squared minus 4. So x squared is equal to 5. So x is plus or minus square root of 5. So your invariant point is square root of 5 comma 1 and negative of square root of 5 comma 1. Understood?
Yeah.
And then we're going to solve for the second. So now you make your y equals to -1. So you put -1 here. So -1 is equal to x squared minus 4, which means x squared is equal to 3, which means x is equal to plus or minus square root of 3. So you would say it's square root of 3 comma -1 or negative square root of 3 comma minus.
Share the Reddit screen.
Understood?
Yeah.
So this is how you can get your invariant points. Does that?
Yeah.
So this part is really complicated. This part is really complicated. I want you to be careful about it.
All right.
Okay. And I don't think you have a test coming up this week, right?
No, not for Pico.
Yeah. So we'll recap this next class as well.
All right.
Okay. You want to do maybe one more question before you leave?
Oh, yeah, sure.
Okay. So if I give you 1 over x squared plus 6x plus 9. If I ask you to graph this, what's the first thing you're going to do? You're just going to graph the bottom. You're just going to graph the bottom first, which is x squared plus 6x plus 9. Now we need to find the vertex, which is your p comma q guy. P is b over 2a, which is going to be -6 over 2, which is -3. To get your q value, you're going to plug in -3 in place of x. Let's go. Plug it in. How much is that? Is that 0?
Yeah.
I think that's 0, right?
Yeah.
Okay, so now we're going to graph this. So my vertex is at -3 comma 0, and we know it's going to open up. Okay, now we need to get the y-intercept and the x-intercept. So let's get the y-intercept and x-intercept.
X.
Yeah. You're right. So my comma 0. Agreed? Okay. Is just going to be at x equals minus 3.
3.
Okay, so we're going to make our vertical asymptote right here. Where do you think the horizontal asymptote is?
On y equals to 0.
0. So that's going to be there, right here. Now we're going to use the same logic. Look, what's happening to the y values? They're becoming really small. So what's going to happen to the reciprocal? It's going to become really,
Big.
and then over here, it's going to become really small. Same over here. Your y values are becoming really small. So your reciprocal is going to become really large. And then over here, it's going to become really small. Does that make sense?
Yeah.
So now you're going to draw your reciprocal graphs. Okay, we will recap this next week because it takes a while to understand. But the bottom line is you graph your bottom denominator separately, and once you've done that, then wherever the x is, that's where you're going to have your vertical asymptote, and then you just take the reciprocal of those. Oh, by the way, invariant points. You know how to get the invariant. These two guys are your invariant points. How would you get those? You make y equals to 1,
And
then you move the 1 over. You move the 1 over, then you're going to have to use quadratic formula to solve it, or maybe not. You can just solve it without. Solve for x's, and then you plug in -1 here, and then you solve for that.
Yeah.
I'm sure you can do that at home. So you're going